You are welcome again to this tutorial question under the elementary differential and integral calculus. We are now in question number 13. Now we are given this question number 13 as half of x squared minus y squared equals to 7y. Then we are asked to find or calculate the y, the x. If you are to solve this problem, all you have to do is to note that we are dealing with an explicit function in this case. An explicit function in the sense that we have to differentiate each terms in a different way. Let me not talk too much. Let me go straight to showing you what I mean. Now, remember what I told you how to differentiate? You power times base, then power minus 1. So here, the coefficient already we have here is half. So write it out, our half, then multiply by power times base, which is 2 x, then power minus 1, which is 2 minus 1. We can differentiate this with respect to x, all right? And that is why we are still having this function. But pay attention to the next term. We do the same thing here, power times base, which is 2y, then power minus 1, which is 2 minus 1. But in this case, we are differentiating. Don't forget differentiation, we use dy, dx. You cannot be having a y in this place. So to show that we are dealing with an explicit function, after writing all of this, I'm going to put my dy, dx in this case. So whenever you are differentiating a y function, you must put dy, dx close to the derivative of that y function. Now we do the same thing here. Don't forget the power here is what? 1. 1 times 7 will give us 7. Then y power what? 1 minus 1. And because this is a y function, we are going to leave it as dy, dx. So in the next step, you notice that these 2, we cancel these 2. You'll be left with what? X. X what? Power 1. All right? Then minus. This will give us 2y power what? 1. Then we're having dy. Then dx equals to what? 7y power 0 dy. And then we have dx. Now, in going further, we have to clear anything we need to clear, like this value for y power 0. So here we have x minus 2y, then dy dx to equals to 7, then dy dx. So in this case now, we can see we need to collect like terms. And if we collect these like terms, our minus 2y dy dx will move to this side. So that will give us 7 dy dx plus 2y dy dx to be equals to this x will stand alone. So we can factorize out the dy dx. So if we do that, we have dy dx, all right, into bracket, we shall have 7 plus 2y, then equals to what? Equals to x. So in this case now, what do we do here? We have to divide our 7 plus 2y by 7 plus 2y on both sides of this differential equation so that we can be able to get the value for dy dx, therefore to be, so dy dx in this case will become x upon 7 plus 2y. Some people may prefer to write it as x upon 2y plus 7. However you write it, the answer is still the same. So